Alright, so let's solve the 6th day of Advent of Code in the God's Temple. So let's take a look at what we have today. Lanternfish, lantern, I don't know how to pronounce this word, I'm sorry. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish, lantern, right, it's like a... okay, so I see what it is, lanternfish. So a massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. You should model their growth rate to be sure. It's very important. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. Okay, so creates a new one once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. Furthermore, you reason a new would surely need slightly longer before it's capable... I'm not really sure I understand this sentence. 2 more days for its first cycle. So suppose you have a lanternfish with the internal timer value of 3. After 1 day, its internal timer would become 2. After another day, its internal timer would become 1. After another day, it becomes 0. After another day, its internal timer would set to 6, and it would create a new lanternfish with an interval timer 8. After another day, the first lanternfish would have an internal timer of 5, and the second lanternfish would have an internal timer of 7. Okay, a lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is introduced as a valid timer value. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Realizing what you're trying to do, imagine like after this phrase, they will say, none of that actually matters, so the actual problem is this. Realizing what you're trying to do, you understand that all of that useless, and let's actually try to find the keys. None of that actually matters. The problem is completely different. The submarine automatically produces a list of ages of several hundred nearby lanternfishes, your puzzle input. For example, suppose you were given the following list: 3, 4, 3, 1, 2. This list means that the first fish has an internal timer of 3, the second one blah 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 blah. Simulating this fish over several days would proceed as follows. Okay, so this is basically what we have. Each day, a 0 becomes a 6 and adds a new 8 to the end of the list, while each other number increases by 1 if it was present at the start of the day. In this example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of 5,934. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? Okay, so that makes sense. That actually makes sense, maybe. Let's try to represent that. So I would assume that, okay, you can go ahead and implement that like in a very dumb way, like having like a list of these things, and that list is going to grow exponentially, right? And I would presume that for the actual puzzle input, it's probably not going to fit into your memory. So what you would do instead, maybe, is actually inverse this list. So essentially you would use the number of days that is left as an index in some sort of array, and the value of that index is going to be how many of such fishes you have. So you sort of like reverse it, and now it becomes actually more like easier to how to say that, to simulate, right? So the timer becomes the index, and the value is how many of such index you have. So this is the first idea that I can see. Right, so let's go ahead and try to implement that. Let me see. So I'll have to start my trusty advent of code TempleOS. So off screen I actually created a couple of helper functions. Essentially like I have a function called new day where I can say day 6, right, and it will actually create like a new file with a predefined template and stuff like that. And here is the new folder, and right, it was created in the appropriate place, and yeah, I don't have to type all of that anymore. Which is quite convenient. So the only thing I need to bring to the virtual machine now is the input, right? So as you can see, input is actually separated by commas, which is actually extremely easy to parse for us. So I think it's actually extremely easy to parse. So let me quickly quit the TempleOS, and I'm gonna mount the entire thing. So this is gonna be AoC, and so now we're going to do home, right? AoC 2021, and it didn't. Wait a second. Where is the 6th day that I just created? Something is extremely fishy. Did I? Are you serious? Okay, so let's actually try to do that one more time. So already started to have some trouble in here. Oh my god. So if I take a look, so there's a 6 of them. Here they are. Right, so this is the 6th one. Am I going crazy? So I forgot to mount, so I'm gonna mount this thing one more time. And if I'm gonna go to here, so here is the home, and AoC 2021. Here's the 6th one. It's just like, I don't know what happened there, so I think I'm going crazy. Anyway, so let's actually create a sample.txt, right? And I'm gonna simply copy paste the sample in there. Right, so here is our sample, a boom, and I'm gonna put a dot and save this entire thing. There we go, here's our sample. So now what I'm gonna do, input.txt as well. So let's insert this thing. And I'm gonna put this stuff in here, and dot save, and there we go. So we have actual input in here. Cool. I'm gonna run AoC 2021, and let me see. Okay. So the first thing I wanna do, I wanna start reading all of these numbers, right? So while SV size is greater than 1, what we're gonna do, we're gonna simply maybe print them. I just wanna make sure that I read all of them correctly. Right, so I'm gonna have something like this. SV chop I64, and I have to provide the SV in here, and if I try to run this entire thing, it didn't actually work. Okay, so let me see. I wonder why. So is that because I have to maybe... Oh, I know why. Because after the number we have a comma. So the thing I have to do SV chop left SV, right? So this is what I have to do. And then if I try to run it, so we have 3, 4, 3, 1, 2, which is 5 values. And I think these are the values that we... Did I just... Okay, so everything's fine. And we have 5 of them. Okay, so everything's fine. All right, that's cool. So the most difficult part of this problem is to understand the rules of this entire stuff, because they're very convoluted intentionally. They're intentionally convoluted, and my brain just cannot follow this entire thing. So suppose you have a lanternfish with internal timer of 3. After 1 day, its internal timer becomes 2. After another day, it becomes 1. Another day, its internal 0. After another day, its internal timer becomes reset to 6, and it would create a new lanternfish with internal timer of 8. Right, after another day, the first lanternfish would have an internal timer of 5, and the second lanternfish... Okay, so that makes sense. That makes a lot of sense, but the problem is I don't understand what was said before. So creates a new lantern every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another, while it have 4. So you can model each as a single number, the number of days until it creates a new lanternfish. Would surely slightly longer. Okay. So a new lanternfish would surely need slightly longer time before it's capable of producing more lanternfish. So 2 days for its first cycle. So they all kind of, when they're created, they all start like at 7 and then plus 2 days. A lanternfish that creates a new resets its timer to 6 and not to 7 because 0 is included as the valid timer value. The new lanternfish starts with an internal timer of and doesn't start counting down until the next day. Realizing what you're trying to do. Okay, I really don't understand what the fuck it's trying to say. Okay, so all right, so what we have here is that this goes to 0, right? It goes to 0, and then it goes, oh, I see. So 0 is basically like part of 7, right? So because 0 is included as a valid timer value, so basically it's done so you can yeah, I see now. So they basically are modded within 7. That's what they do. They're modded within 7. And the new one is basically longer by 2, right? It's usually need like a little bit longer time. But they never actually grow bigger than 8, if you notice that. They never grow bigger than 8, so that means we can just have a table, right, of 9 values, including 0, right? So that's basically what we can have in here. Should be pretty straightforward. Okay, so I think I'm starting to understand. So I just needed to like talk through this entire stuff. So I'm going to define the size of the table. So it's going to be n, and as I already said, there will be like 9 values in here. So let's actually call this thing a table, right? So this is going to be table 9, and maybe before reading this entire stuff, it would make sense to memset everything. Right, so this is going to be memset, and we're going to set the table, then we're going to set it to value, size of i64. I'm never using memset i64 anymore, right? I mean, again, because that actually kind of like messes up with my brain, because you have to think like bytes versus elements, and it's always like very, very easy to screw up. Okay, so here, what we're gonna do, I think I'm gonna just go ahead and assign whatever we managed to parse to x, and in here we're gonna have i64x. So let me double check. So input is probably never gonna have anything that is bigger than even 7, so that's totally fine, right? Of course, I accidentally pressed Shift escape instead of escape, and it didn't save any of my changes, right? Yeah, okay, sure. One more time. So I'm going to define n. This is going to be 9. i64 table n. There we go. So I have to type that yet again. Memset table 0, size of i64 multiplied by n, right? And let me just go and set this entire thing like that, right? Thank you so much to Demigods for subscription. Thank you. Really appreciate the subscription. Really appreciate the support. Okay, so let me do the following thing. I kind of want to double check. Well, maybe it's not necessary, right? So I want you to basically assert. I can assert. Wait a second. I can assert. This is actually very cool. So I wonder what's going to happen if you try to assert that. So assert. What's going to happen if you like fail the assertion? That is a very interesting question. So let me actually try to run assert false in here. So what happens? So basically it throws some sort of an exception. All right, that's pretty cool. I can't see what's behind the camera though. Right, so it's basically assertion false. All right, so maybe I'm going to use assertion for unreachable things and stuff like that, because that's pretty convenient. All right. So I'm going to assert that x is going to be less than n, right? So that's very important assertion that I always want to check. For some reason, my brain thought that maybe I'm programming in Go, and in Go there is no asserts because Go was designed for servers, and servers are supposed to run in 24/7, right? So like assertion actually encourages the developers to not check for the errors and stuff like that, and all of that bullshit that nobody listens to and panic anyway, right? So assertion is very important feature for programming languages. I don't know like how they decided it's not, as well as generics. So anyway, so then I'm gonna take the table, all right, so this is gonna be x, and I just do plus plus. There we go. So one of the things I probably want to be able to do, I want to be able to maybe dump the table. Right, so let's actually dump the table, and we're gonna use that function as sort of like a debug facility while we're developing things, right? So it's gonna be dump table. Right, so it's gonna be something like that. I64 I4 I equals 0, I less than n, plus plus I. All right, and in here we're gonna do the following stuff. So 2d, I suppose, right? So I think it's the easiest thing to do in here, and then just d. So in here I'm gonna use the number itself and then the counter within the table, right? So, and that is basically it. I didn't think we need anything else. So if I try to run this entire stuff, so it didn't work out because why? Undefined identifier, because I don't have x defined anywhere. So let's actually quickly define that thing in here. So it still didn't compile. Missing expression, compiler error at x. Really? Huh. Missing expression assert. Excuse me, am I using assert incorrectly? I don't even know how you're supposed to use assert. I just realized that. So, but luckily we are in TempleOS. In TempleOS it should be super easy to look for examples. Let's actually go to the home folder, right? And there is a very cool function called a find, right? So if you go into the definition of the things, it basically finds occurrences of a string in files. And as you can see, it can accept file masks. So it actually does that recursively. So that means you can use that function to find some sort of examples of usage, right? So let's actually go somewhere, I don't know, here, right, at the root of the C, and then I'm gonna say find assert, right? So how do you even use assert? It's gonna actually give you a lot of shit, as you can see. So there's a lot of assertions, and apparently you're supposed to use assert like this. Right, so we can see things like that, and it feels like it's more of a compile time assert, which is kind of interesting. So apparently, I'm really sorry, the encoding right now is probably shit, right, because there's a lot of things on the screen. I really apologize for that. But it feels like, right, so this is a compile time assert. So it might not actually work for us, unfortunately. Okay, so I'm gonna actually maybe go to here, like so, and let me take a look at this stuff. So AoC 06 and 07. So if I try to just do something like this, will it work? Assert failed in part, and okay, so that's very interesting. So apparently I probably don't want to use that at all, so let's actually get rid of that. And one of the things I forgot to put like a new line in here. Let me quickly do that. So there we go. So we have our table. We have our table that we're trying to simulate. All right, so let me see. So one of the things we probably want to do, we want to have a function that simulates the next day, right? So let's do next day, something like this. So this is going to be the next day. And in here, so let me see how it is usually done, right? How it is usually done. So you reach the 0, right? And then whatever reaches 0 on the next day becomes 6, and then it spawns another one which is 8. Right, so that kind of makes sense. So what I'm thinking is that, can I do everything in place? Probably not, right, if you know what I'm talking about. So I probably will need like 2 tables, right? I will have to be a 2-time champion of the table. And essentially, I will have to iterate through the first table and collect the final results into the new one. Right. So, shouldn't be that difficult because the tables are really small, so I can basically have some sort of a back table. And then once I'm done computing everything into the back table, I can just mem copy it into the original table. And since, again, the table is very small, it's going to be very fast operation. So I think I'm going to go with that approach. So I'm going to have this back table in here. So I64, this is going to be back table. Back table. All right, and how are we gonna approach this entire stuff? I0, I plus I. All right, so, and there is a couple of, well, I mean, I suppose you can do the following thing, right? So essentially, the only thing that requires a special treatment is I equal to 0, right? So that means here we can iterate only from 1, right? And in here we can just take table 0, so these are everything that is table 0, and then we're gonna basically assign them to, maybe even add them to the back table 8, right? So these things become 8. Furthermore, maybe one of the things I want to do before even using back table is to clean it, right? So I'm going to do mem set. By the way, is there something like mem 0? Right, so maybe 0, maybe it's B0. Mem... Let's use mem set. I'm not sure if there's like mem 0 or something like that. So back table, we set it to 0, then I take size of I64 and I multiply that by n. So we set it to 0. Okay, so here I have that, and essentially everything that was a 0 becomes 8, right? And after that, I suppose. So we'll have to take 6, right, and add all of these things as well, right, I think. I suppose, right? I suppose that's what you would do. Okay. Then what we need to do, we need to take table I, right? So, and everything in table I will become table I minus 1, right? And since we start with I equal 1, that should be a valid thing. That should be straight up a valid thing. Actually plus, we have to do plus, right? Is that it? I think that is it, right? So, and after that we can just like copy the back table into the original one. Let me take a look. So it's gonna be mem copy, and then I'm gonna just go into the definition of this thing. So it accepts the destination first and then the source. Right, so the destination is gonna be table, back table, and we're gonna do size of I64, and we wanna copy n of those things, right? So that's pretty much it. So is that what it is, right? So I think that's what it is, if I'm not mistaken. So all right, so here's that one. So maybe I want to actually put a little bit of a line between the days. Then I'm gonna say next day, please. Right, and then I'm gonna dump the table just to see what the next day looks like. Right, so, and it doesn't even compile, so it fails at the line 30. Let's take a look at the line 30. So I don't have I. Okay, so that's fine. I64I, so if I try to do this, okay. Oh, you can even kind of see how they... Alright, that's cool. This is actually kind of cool. Right. So, let me take a look. Yeah, so one of them becomes 0, you have 1, 1, 2 2s and 1 3. Right, and then we can try to simulate. Okay, so I would like to take a look at the table in a original way, right? But I think in a way as it's shown in here, right? Because the way we represent is actually doesn't show the exact picture. So I would like to just see how it goes, but I'm not quite sure. So maybe that's fine. All right, so whatever. I'm gonna do another day and just see how it will go. So I need to copy paste this stuff and then run this entire thing. And this is what we have. Right, this is what we have. So on top of that, it would be nice to have a thing that tells us how many fishes we have. Count fish. Right, so in here we're gonna just take that I64i. For I equals 0, less than n, plus I. So we also need some sort of a result. I64 result, result equals 0. Then this is the result, plus equal table I. Alright, and then I just return the results. So now I can count fishes. And instead of dumping the tables, we might as well just actually print the how many fishes we have, right? So d count fish, right? So this is the count fish. Then I'm gonna copy paste this thing. Next day, count fish. Next day, there we go. So then we have 6 and so on and so forth. All right, so now we can try to simulate this entire thing. So 18 day, on 18 day, so day 1. All right. So let's go ahead and create an iterator, right? Let's go ahead, create an iterator. So it's going to be for I equals 0, less than 18. I just want to see if the result is correct. All right, and then I do the following thing, next day, and then I'm gonna count the fish, right? So how many of those things we have? So we have 26 of them. Is that correct? Is that correct? 26, right? So 26 fishes, and after 18 day, we should have like 5,000 something, something, something. Okay, so 80, not 18, 80, right? So 5934, 5934. Okay, so that looks reasonable. That looks actually correct. And this is effectively a part 1, right? So this is a part 1. And now I can try to switch to the actual input. Right, so this is going to be 0, and probably in our case the answer is going to be 353,274. So let's try to submit that. I don't know, maybe it will work, maybe it will not. All right, 353,274, and it's a correct answer. How about that? First try. So yeah, that's what we got. Isn't that cool? Isn't that cool? I think it's pretty fucking cool. Read the lines after that example. It explains how the spawning works every day. Thank you so much to Demigods. I really appreciate your help. Alright. Funk Chi, thank you so much for 29 months of tier 1 subscription. Thank you, thank you, thank you. Alrighty. So there was assert with uppercase A. Okay, let's take a look at the assert with capital A. Assert. There's no such thing, unfortunately. It simply does not exist. I'm not even surprised, by the way. I'm not surprised. So I probably wanna, you know what, I'm gonna actually close the emulator because I need to commit this entire thing anyway. Okay, so let's take a look at the status. Right, so I wanna now sync into the host, right? So AoC 2021. All right, there we go. By the way, I'm actually now committing the whole home folder into the repo. So by the way, you can find the source code in here in the description if you're watching on YouTube, or you can find it in here if you're watching live. Right. So because now the source code also includes some configuration stuff in HomeSys. Right. In HomeSys, I just changed how the initial windows spawn. Instead of two windows, now I have one full screen window. And I also have a special function that creates a new day, right? New day. And it's actually a pretty cool function. It creates a new folder, then copies the template, then CDs there, moves it, and opens the editor automatically for you, right? So you can do this kind of stuff in TempleOS to automate your work if you want to, of course. So this is actually kind of cool. So yeah, and if I take a look at the status now, right, so I can add home, right, so as you can see, we added the first solution, so I'm going to do commit, so add day 06 part 1, there we go, I'm going to push that right into the repo. Having C as a scripting language is so cool. It is kind of cool, actually. I wish it would also type check these scripts. Apparently, HolyC doesn't even type check at all. It's not a thing. So if your types don't match, it's basically gonna compile and generate assembly, but it's simply gonna be incorrect assembly. That's how it works. It's not gonna throw a compile time error, and it's not gonna throw even a runtime error that is useful for you. It's probably gonna crash, but it's gonna crash because it's generated gibberish in assembly. And you won't know why. Right? So that it is what it is. You have to be super careful when you're programming in this language. Well, you have to have a divine intellect. Unfortunately, I don't have a divine intellect. Okay, continue to part 2. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example above, there would be a total of lanternfish. Lanternfish live forever and have unlimited food space. Is that it? Really? Wait a freaking second. Are you serious? Okay, so let me see. It's gonna be 06, and I'm gonna just go here. And now, all right, so I'm gonna go into the one, right? So this is the sample, and in sample 5934. Right, so now instead of like this one, it's gonna be 256, right? So if I run this thing, it's 269. Is it the same? 269.39. Okay. So though maybe something could overflow. So is it gonna overflow 64 bits? I mean, I don't know. Maybe. So let me now try this thing. And okay. One of the things, like, I don't really wanna, you know, retype all of that. So what I'm gonna do, I'm gonna just copy paste this entire thing. And I'm gonna open something like ed output txt, right? So I'm gonna do it like that. Not a text file. Okay. Oh, I know why. Because you have to say txt all in capital letters. Sure. Thank you very much. Okay, so this is gonna be that, and I can now save everything and quit the virtual machine, and then mount my virtual machine. So it's gonna be AoC 2021, and then I'm gonna go into mnt home AoC 06 output txt. So okay, so maybe now I should be able to copy paste this entire thing. So, and the question is that the answer? It is apparently the answer. So the trick to this problem was to realize that you have to use that hash table, because effectively what you're using hash table. It's just like your hashing is perfect. Right, so your hash function matches each individual possible key to a unique cell. So yeah, I guess the trick here was to realize that. So I suppose it was expected that first you would try to literally simulate something like this. It will work for the part 1, probably will be slow, and then you would see that the number has increased and will think, holy shit, how do I simulate that? And then you'll supposed to come up with that table idea. Okay, fair enough, I guess. Fair enough. I don't know. So, all right. I actually used a list for part 1, so I had to rewrite it, so that's why it actually worked for me. Oh, I see. There is a little bit of like a game design to these problems, right? So you're trying to design a problem to store the person who's solving in a particular direction, and then on a part 2, you're trying to hit them with some sort of like a plot twist. And there's a lot of like elements of game design in here, which is kind of cool. Right, so it's really interesting. I used the vector 28 gigabytes later with the same input for part 2, and I realized that will not work. Yeah, I see why it will work. I don't know, like I saw that their values don't go very high, and my competitive programming instincts totally, like, instantly told me that this could be an index in an array, right? Because I've been doing competitive programming in university, and I just like kind of, I don't know, I've never was good at competitive programming, but I developed a couple of instincts when it comes to the input data. Usually you look at the input data and you see how you can exploit like different parts of the input data. Right. So I kind of know how to do competitive programming, but I was never good at it, right? So.